Hello friends, this is Praveen. Welcome to my channel Technical Talks. So today we are going to discuss what is factory design pattern. If you find this video helpful, so please subscribe to my channel. Thank you.
Hello friends. So in this video, let's understand what is factory design pattern with simple example. Please watch this video till end. So basically design patterns are solutions to software design problems that we find again and again in our real-time application development. And patterns are about reusable designs and interaction of the objects. So factory design pattern is one of the most frequently used design pattern in real-time applications. In factory design pattern, we create an object without exposing the creation logic to the client, and client will refer to the newly created object using a common interface. That is our factory. So in simple words, if we have a superclass and there are n number of subclasses, and based on the data provided, if we have to create and return the object of one of the subclasses, then in that case we would need to use factory design pattern. In this pattern, an interface is used for creating an object, but let subclass decide which class to instantiate. The creation of object is done when it is required. So object creation process follows client uses factory, and factory is responsible to create an object for the product classes. The factory in factory class, that is abstract class, allows a class later instantiation of the subclasses. In short, in this pattern, abstract the process of object creation and allow the object to be created at the runtime when it is actually required. So let's understand this concept with the simple example. For example, if I'm having gym management system and there are two plans, monthly and yearly. So user has to input the package type, that is monthly or yearly, and based on that the get membership charges method from gym interface or class should return me the charges. So let's understand the factory design pattern with this example. And the basic principle behind this pattern is at runtime we get an object of similar type based on the parameter that we pass. So this is how the structure of factory design pattern. On right hand side, if you see in a number, that is first is product, which is nothing but an interface. Number two, concrete product, which implements the interface. Number three, that is creator. Creator is an abstract class with the factory method declared. And fourth one is concrete creator, which implements this creator class and override its factory method to return an instance of concrete product. That means when client asks for a new object, then factory as a creator, that means that is the abstract class, will be responsible to create an object through the concrete creator class, and that creates an object for the concrete product. Indirectly it implements an interface. So let's see this in action. First, let's discuss how to achieve this without using the factory design pattern, and later we will discuss the problems, and finally we will create the same application using factory design pattern. So let's switch to Visual Studio and let's see how to implement that without factory. So let me create one application that is without factory class or without factory. Okay, so this is my client. Let me create an interface first. I will name this as gym. Here, as per the requirement, we would need the charges. So let me declare one method, get charges. So we are done with an interface. Let's create product classes. let me name this as monthly, which implements this interface. So if you right click and if you click on implement interface, so it should return you. Let's return 2000. Similarly, let's create one more class and implement the same interface. And in this method, let's return 8000. Okay, so we are done with the interface, that is our product. We are done with the classes, that are product classes. Now, so in traditional approach that uh, we used to make this as obj equal to new. I'm sorry, null. Then we will write if console.writeLine. We will ask user which membership you want, and then read the type of membership from console.readLine, and then we will have if else condition. If type equal to monthly, then let's create an object of monthly class. Else if type is yearly, then let's create object of yearly class. And finally, let's print the output. obj.getCharges, okay, that we implemented. Okay, so let's run this application. Hopefully it should, yeah, it should work with charges what we want, for example monthly. Okay, great. So if I enter monthly, then it should return me 2000. So that is good. So this is the traditional approach that is without this factory design pattern. So what is the problem of the above code? Okay, so the first problem is it is tight coupling between client class and the product classes, that is monthly and yearly. Second, tomorrow, if in future, if I need one more type, for example half yearly, then in that case I need to change my main method by adding that extra if else condition for half yearly. So again, that is not so feasible in development and testing. Okay, so let's see how to overcome this problem by using factory design pattern. So let's modify this code. So in order to implement factory design pattern, we would need to introduce the factory class, that is nothing but the abstract class. Okay, so let's that is public abstract. I will name this as membership factory. Oh, public class. And I will have one method, that is abstract method of type interface, and name this method as get gym membership type, membership type, and it will accept string parameter. Okay, so this is our factory class, that is nothing but the creator. Okay, so this class provides an interface for product creation in its derived classes. So now let's implement our concrete creator classes and override this method. So let me create one more class. I will name this as concrete membership, and let me inherit this from factory, membership factory. Okay, and now let's override the method from this abstract class. Okay, so this is the abstract class, that is factory. Inside we have an abstract method of type asgym, and we have overridden this method. Now based on this type provided, we are going to create an object of the product classes. Okay, so currently we have two product classes, monthly and yearly, and based on the type, this type, we are going to uh, create an object. So let's use this switch. So when it's monthly, then return a new object. Okay, the object of monthly. Case yearly, then return its object. If not, then default. Okay, it is there. Let's throw this application exception. Yes. Okay, not available. Of type. Okay, excellent. So now we are ready to start using our factory methods. So in this case, we have used a switch statement, which is basically based on this type. We are going to generate the object. I am sorry. Okay, so we are done with the creator class, and here this is our concrete creator. Okay, so in client, let's get rid of this code, that is the code which we used to use in your traditional way. So we don't want to create an object in a client, because basically factory design pattern, we don't create any object, we don't expose the creation logic to the client. So let's get rid of this. Let's create an object of factory, that is membership factory, which new concrete membership, and then let's ask user input, asking for which membership. charges you want. If it is yearly or monthly, then string type, let's accept console read line, and then let's invoke the factory method of type igem instance, and let's invoke the factory method and pass this type. So it will create an object on runtime based on this type, that is monthly or yearly, and then let's print the method from object.getCharges. I'm sorry, instance.getCharges. Okay, let's run this. Let me input yearly. Okay, great. So we have successfully implemented factory design pattern. Okay, the traditional approach we have commented out because we don't want to use the logic of object creation in class. So we have asked factory to get the factory method of type igem from the abstraction, and runtime it will decide the instance, okay, of the class based on the type, and it will invoke that get charges method of a respective class, and it will print the charges, whether it is monthly charges or that is yearly charges. Okay, so in next video we will see what is abstract factory design pattern. So please subscribe to my channel and click on bell icon to get notification when I post new video. Thank you so much for your time.